Movable type is the system and technology of printing and typography that uses movable components to reproduce the elements of a document, usually on the medium of paper, which was first invented in ancient China. The world's first movable type printing press technology for printing paper books was made of ceramic porcelain China materials and invented in ancient China around AD 1040 by the Han Chinese innovator Bi Sheng during the Northern Song Dynasty. In 1377, currently the oldest extant movable metal print book, Jikji, was printed in Korea. The diffusion of both movable type systems was, however, limited. They were expensive, and required a high amount of labor involved in manipulating the thousands of ceramic tablets or metal tablets required for scripts based on the ancient Chinese writing script, which has hundreds of thousands of characters. Around 1450, Johannes Gutenberg made another version of a metal movable type printing press in Europe, along with innovations in casting the type based on a matrix and hand mold. The more limited number of characters needed for European languages was an important factor. Gutenberg was the first to create his timepieces from an alloy of lead, tin, and antimony, and these materials remained standard for 550 years. For alphabetic scripts, movable type page setting was quicker than woodblock printing. The metal timepieces were more durable and the lettering was more uniform, leading to typography and fonts. The high quality and relatively low price of the Gutenberg Bible established the superiority of movable type in Europe, and the use of printing presses spread rapidly. The printing press may be regarded as one of the key factors fostering the Renaissance, and due to its effectiveness, its use spread around the globe. The 19th century invention of hot metal typesetting and its successors caused movable type to decline in the 20th century. Precursors to movable type: letter punch in coins. The technique of imprinting multiple copies of symbols or glyphs with a master type punch made of hard metal first developed around 3000 BC in ancient Sumer. These metal punch types can be seen as precursors of the letter punches adapted in later millennia to printing with movable metal type. Cylinder seals were used in Mesopotamia to create an impression on a surface by rolling the seal on wet clay. They were used to sign documents and mark objects as the owner's property. Cylinder seals were a related form of early typography capable of printing small page designs in relief on waxy clay, a miniature forerunner of rotogravure printing used by wealthy individuals to seal and certify documents. By 650 BC, the ancient Greeks were using larger diameter punches to imprint small page images onto coins and tokens. The designs of the artists who made the first coin punches were stylized with a degree of skill that could not be mistaken for common handiwork, salient and very specific types designed to be reproduced ad infinitum. Unlike the first typefaces used to print books in the 13th century, coin types were neither combined nor printed with ink on paper, but published in metal, a more durable medium, and survived in substantial numbers. As the portable face of ruling authority, coins were a compact form of standardized knowledge issued in large editions, an early mass medium that stabilized trade and civilization throughout the Mediterranean world of antiquity. Seals and stamps. Seals and stamps may have been precursors to movable type. The uneven spacing of the impressions on brick stamps found in the Mesopotamian cities of Uruk and Larsa, dating from the 2nd millennium BC, has been conjectured by some archaeologists as evidence that the stamps were made using movable type. The enigmatic Minoan Phaistos disc of 1800 to 1600 BC has been considered by one scholar as an early example of a body of text being reproduced with reusable characters. It may have been produced by pressing pre-formed hieroglyphic seals into the soft clay. A few authors even view the disc as technically meeting all definitional criteria to represent an early incidence of movable type printing. Recently it has been alleged by Jerome Eisenberg that the disc is a forgery. Woodblock printing. Following the invention of paper in the 2nd century AD during the Chinese Han Dynasty, writing materials became more portable and economical than the bones, shells, bamboo slips, metal or stone tablets, silk, etc. previously used. Yet copying books by hand was still labor-consuming. Not until the Xiping era, towards the end of the Eastern Han Dynasty, did sealing print and monotype appear. It was soon used for printing designs on fabrics, and later for printing texts. Woodblock printing, invented by about the 8th century during the Tang Dynasty, worked as follows. First, the neat hand-copied script was stuck on a relatively thick and smooth board with the front of the paper, which was so thin that it was nearly transparent, sticking to the board, and characters showing in reverse, but distinctly, so that every stroke could be easily recognized. Then carvers cut away the parts of the board that were not part of the character, so that the characters were cut in relief, completely differently from those cut in intaglio. When printing, the bulging characters would have some ink spread on them and be covered by paper. With workers' hands moving on the back of paper gently, characters would be printed on the paper. By the Song Dynasty, woodblock printing came to its heyday. Although woodblock printing played an influential role in spreading culture, there remained some apparent drawbacks. Firstly, carving the printing plate required considerable time, labor and materials. Secondly, it was not convenient to store these plates, and finally, it was difficult to correct mistakes. With woodblock printing, one printing plate could be used for tens of hundreds of books, playing a magnificent role in spreading culture. Yet carving the plate was time and labor-consuming. Huge books cost years of effort. The plates needed a lot of storage space, and were often damaged by deformation, worms and corrosion. If books had a small print run, and were not reprinted, the printing plates would become nothing but waste, and worse, if a mistake was found, it was difficult to correct it without discarding the whole plate. History. Prior to the development of metal movable type, most printing was done using blocks carved from wood. Woodblock printing was used extensively in East Asia and created the world's first print culture. Ceramic movable type. Bi Sheng developed the first known movable type system for printing in China around 1040 AD during the Northern Song Dynasty, using ceramic materials. As described by the Chinese scholar Shen Kuo, when he wished to print, he took an iron frame and set it on the iron plate. In this he placed the types set close together. When the frame was full, the whole made one solid block of type. He then placed it near the fire to warm it. When the paste was slightly melted, he took a smooth board and pressed it over the surface, so that the block of type became as even as a whetstone. For each character there were several types, and for certain common characters there were 20 or more types each. In order to be prepared for the repetition of characters on the same page, when the characters were not in use, he had them arranged with paper labels, one label for each rhyme group, and kept them in wooden cases. If one were to print only 2 or 3 copies, this method would be neither simple nor easy, but for printing hundreds of thousands of copies, it was marvelously quick. As a rule, he kept 2 forms going. While the impression was being made from the one form, the type was being put in place on the other. When the printing of the one form was finished, the other was then ready. In this way the 2 forms alternated and the printing was done with great rapidity. In 1193, Chodowiecki, an officer of Southern Song Dynasty, made a set of clay movable type method according to the method described by Shen Kuo in his Dream Pool essays, and printed his book Notes of the Jade Hall. The claim that Bi Sheng's clay types were fragile and not practical for large-scale printing, and short-lived, was refuted by facts and experiments. Bi Sheng read that baked clay movable type was as hard and tough as horn. Experiments show that clay type, after being baked in an oven, becomes hard and difficult to break, such that it remains intact after being dropped from a height of 2 meters onto a marble floor. Korea could have tried clay movable type, but with little success, probably due to misinterpretation of Shenkua's description as thin as coin, which likely referred to the depth of the character matrix, not the total length of the movable type body. The length of clay movable types in China was 1 to 2 centimeters, not 2 millimeters, thus hard as horn. There has been an ongoing debate regarding the success of ceramic printing technology, as there have been no printed materials found with ceramic movable types. However, it is historically recorded to have been used as late as 1844 in China from the Song Dynasty through the Qing Dynasty. Wooden movable type. Bi Sheng also pioneered the use of wooden movable type around 1040 AD, as described by the Chinese scholar Shen Kuo. However, this technology was abandoned in favor of clay movable types due to the presence of wood grains and the unevenness of the wooden type after being soaked in ink. In 1298, Huang Zhen, a Yuan dynasty governmental official of Jingde County, Anhui Province, China, reinvented a method of making movable wooden types. He made more than 30,000 wooden movable types and printed 100 copies of Records of Jingde County, a book of more than 60,000 Chinese characters. Soon afterwards, he summarized his invention in his book A Method of Making Movable Wooden Types for Printing Books. Although the wooden type was more durable under the mechanical rigors of handling, repeated printing wore the character faces down, and the types could only be replaced by carving new pieces. This system was later enhanced by pressing wooden blocks into sand and casting metal types from the depression in copper, bronze, iron or tin. This new method overcame many of the shortcomings of woodblock printing. Rather than manually carving an individual block to print a single page, movable type printing allowed for the quick assembly of a page of text. Furthermore, these new, more compact type fonts could be reused and stored. The set of wafer-like metal stamp types could be assembled to form pages, inked, and page impressions taken from rubbings on cloth or paper. In 1322, a Fenghua County officer Ma Chengjian Zhejiang made 100,000 wooded movable types and printed 43-volume Daxueyani. Wooden movable types were used continually in China, even as late as 1733. A 2,300-volume Wang Palace Collected Gems edition was printed with 253,500 wooden movable type on order of the Yongzheng Emperor, and completed in 1 year. A number of books printed in Tangut script during the Western Xia period known, of which the auspicious Tantra of all-reaching union that was discovered in the ruins of Beizagu Square Pagoda in 1991 is believed to have been printed sometime during the reign of Emperor Renzong of Western Xia. It is considered by many Chinese experts to be the earliest extant example of a book printed using wooden movable type. The logistical problems of handling the several thousand logographs posed a particular difficulty. It was faster to carve one wood block per page than to composite a page from so many different types. However, if one used movable type to produce multiple copies of the same document, the speed of printing would increase relatively. Metal movable type in China. At least 13 material finds in China indicate the invention of bronze movable type printing in China no later than the 12th century, with the country producing large-scale bronze plate printed paper money and formal official documents issued by the Jin and Southern Song dynasties with embedded embedded bronze metal types for anti-counterfeit markers. Such paper money printing might date back to the 11th century Jikji of Northern Song. The typical example of this kind of bronze movable type embedded copper block printing is a printed check of the Jin dynasty with two square holes for embedding two bronze movable type characters, each selected from 1,000 different characters, such that each printed paper money has different combination of markers. A copper block printed paper money dated between 1215 to 1216 in the collection of Luo Zhenyu's pictorial paper money of the Four Dynasties, 1914, shows two special characters, one called Ziliao, the other called Zihao, for the purpose of preventing counterfeit. Over the Ziliao there is a small character printed with movable copper type, while over the Zihao there is an empty square hole. Apparently the associated copper metal type was lost. Another sample of Song Dynasty money of the same period in the collection of Shanghai Museum has two empty square holes above Ziliao as well as Zihou, due to the loss of the two copper movable types. Song Dynasty bronze block embedded with bronze metal movable type printed paper money was issued on a large scale and remained in circulation for a long time. The 1298 book Zhao Huo Ziyin Sufa of the Yuan dynasty official Wang Zhen mentions tin movable type, used probably since the Southern Song dynasty, but this was largely experimental. It was unsatisfactory due to its incompatibility with the inking process. During the Mongol Empire, printing using movable type spread from China to Central Asia. The Uyghurs of Central Asia used movable type, the script type adopted from the Mongol language, some with Chinese words printed between the pages, strong evidence that the books were printed in China. During the Ming dynasty, Hua Sui in 1490 used bronze type in printing books. In 1574 the massive 1,000-volume Encyclopedia Imperial Readings of the Typing Era was printed with bronze movable type. In 1725 the Qing dynasty government made 250,000 bronze movable type characters and printed 64 sets of the encyclopedic Gujin Tu Shuji Cheng. Each set consisted of 5,040 volumes, making a total of 322,560 volumes printed using movable type. Metal movable type in Korea in 1234. The first books that are known to have been printed in metallic typeset were published in Goryeo dynasty in Korea. These are a set of ritual books, Sangjeng Gojim Yemun. This is credited to Cho Yun-ui. While these books are not extant, the oldest book in the world that was printed in metallic movable types is Jikji, printed in Korea in 1377. Examples of this metal type are on display in the Asian Reading Room of the Library of Congress in Washington, D.C. About the invention of the metallic types by Koreans, French scholar Henry Jean Martin described this as to Gutenberg's. The techniques for bronze casting, used at the time for making coins, were adapted to making metal type. The following description of the Korean font casting process was recorded by the Joseon dynasty scholar Seong I-in. At first one cuts letters in beechwood. One fills a trough level with fine sandy of the reed-growing seashore. Wood-cut letters are pressed into the sand, then the impressions become negative and form letters. At this step, placing one trough together with another, one pours the molten bronze down into an opening. The fluid flows in, filling these negative molds, one by one becoming type. Lastly, one scrapes and files off the irregularities and piles them up to be arranged. A potential solution to the linguistic and cultural bottleneck that held back movable type in Korea for 200 years appeared in the early 15th century, a generation before Gutenberg would begin working on his own movable type invention in Europe, when Sejong the Great devised a simplified alphabet of 24 characters for use by the common people, which could have made the typecasting and compositing process more feasible. Adoption of the new alphabet was stifled by Korea's cultural elite, who were appalled at the idea of losing Hanja, the badge of their elitism. Proliferation of movable type was also obstructed by Confucian prohibition on the commercialization of printing, restricted the distribution of books produced using the new method to the government. The technique was restricted to use by the Royal Foundry for official state publications only, where the focus was on reprinting Chinese classics lost in 1126 when Korea's libraries and palaces had perished in a conflict between dynasties. There is some scholarly debate and speculation as to whether Eastern movable type was spread to Europe between the late 14th century and early 15th century. Metal movable type in Europe. Johannes Gutenberg of Mainz, Germany is acknowledged as the first to invent a metal movable type printing system in Europe, the printing press. Gutenberg was a goldsmith familiar with techniques of cutting punches for making coins from molds. Between 1436 and 1450 he developed hardware and techniques for casting letters from matrices using a device called the hand mold. Gutenberg's key invention and contribution to movable type printing in Europe. The hand mold was the first practical means of making cheap copies of letter punches in the vast quantities needed to print complete books, making the movable type printing process a viable enterprise. Before Gutenberg, books were copied out by hand on scrolls and paper, or printed from hand-carved wooden blocks. It was extremely time-consuming. Even a small book could take months to complete, and because the carved letters or blocks were flimsy and the wood susceptible to ink, the blocks had a limited lifespan. Gutenberg and his associates developed oil-based inks ideally suited to printing with a press on paper, and the first Latin typefaces. His method of casting type may have been different from the hand mold used in subsequent decades. Detailed analysis of the type used in his 42-line Bible has revealed irregularities in some of the characters that cannot be attributed to ink. Spreader type wear under the pressure of the press. Scholars conjecture that the typepieces may have been cast from a series of matrices made with a series of individual stroke punches, producing many different versions of the same glyph. It has also been suggested that the method used by Gutenberg involved using a single punch to make a mold, but the mold was such that the process of taking the type out disturbed the casting, creating variants and anomalies, and that the punch matrix system came into use possibly around the 1470s. This raises the possibility that the development of movable type in the West may have been progressive rather than a single innovation. Gutenberg's movable type printing system spread rapidly across Europe, from the single Mainz printing press in 1457 to 110 presses by 1480, of which 50 were in Italy. Venice quickly became the center of typographic and printing activity. Significant were the contributions of Nikolaus Jensen, Francesco Griffo, Aldus Manutius, and other printers of late 15th century Europe. Type founding. type founding as practiced in Europe and the West consists of 3 stages. Punch cutting. If the glyph design includes enclosed spaces, then a counterpunch is made. The counter shapes are transferred in relief onto the end of a rectangular bar of mild steel using a specialized engraving tool called a graver. The finished counterpunch is hardened by heating and quenching, or exposure to a cyanide solution. The counterpunch is then struck against the end of a similar rectangular steel bar, the letterpunch, to impress the counter shapes as recessed spaces. The outer profile of the glyph is completed by scraping away with a graver the material outside the counter spaces, leaving only the stroke lines of the glyph. Progress toward the finished design is checked by successive smoke proofs, temporary prints made from a thin coating of carbon deposited on the punch surface by a candle flame. The finished letterpunch is finally hardened to withstand the rigors of reproduction by striking. 1 counterpunch and 1 letterpunch are produced for every letter or glyph, making up a complete front matrix. The letterpunch is used to strike a blank die of soft metal to make a negative letter mold, called a matrix. Casting. The matrix is inserted into the bottom of a device called a hand mold. The mold is clamped shut and molten type metal alloy consisting mostly of lead and tin, with a small amount of antimony for hardening, is poured into a cavity from the top. Antimony has the rare property of expanding as it cools, giving the casting sharp edges. When the type metal has sufficiently cooled, the mold is unlocked and a rectangular block approximately 4 cm long, called a sort, is extracted. Excess casting on the end of the sort, called the tang, is later removed to make the sort the precise height required for printing, known as type height. The type height was quite different in different countries. The Monotype Corporation Limited in London, UK produced molds in various heights: 0.918 inches, United Kingdom, Canada, US, 0.928 inches, France, Germany, Switzerland and most other European countries. 0.933 inches, Belgium height. 0.9785 inches, Dutch height. A Dutch printer's manual mentions a tiny difference between French and German height: 62.027 equals 23.30 mm equals English height. 62.666 equals 23.55 mm equals French height. 62.685 equals 23.56 mm equals German height. 66.047 equals 24.85 mm equals Dutch height. Tiny differences in type height will cause quite bold images of characters. Typesetting. Modern, factory-produced movable type was available in the late 19th century. It was held in the printing shop in a job case, a drawer about 2 inches high, a yard wide, and about 2 feet deep, with many small compartments for the various letters and ligatures. The most popular and accepted of the job case designs in America was the California job case, which took its name from the Pacific Coast location of the foundries that made the case popular. Traditionally, the capital letters were stored in a separate drawer case that was located above the case that held the other letters. This is why capital letters are called uppercase characters, while the non-capitals are lowercase. Compartments also held spaces, which are blocks of blank type used to separate words and fill out a line of type, such as M and N quads. An M space was the width of a capital letter M, as wide as it was high, while an N space referred to a space half the width of its height. Individual letters are assembled into words and lines of text with the aid of a composing stick, and the whole assembly is tightly bound together to make up a page image called a form, where all letter faces are exactly the same height to form a flat surface of type. The form is mounted on a printing press. A thin coating of viscous ink is applied and impressions made on paper under great pressure in the press. Sorts is the term given to special characters not freely available in the typical typecase, such as the @ mark. Metal type combined with other methods. Sometimes it is erroneously stated that printing with metal type replaced the earlier methods. In the industrial era, printing methods would be chosen to suit the purpose. For example, when printing large-scale letters in posters etc., the metal type would have proved too heavy and economically unviable. Thus, large-scale type was made as carved wood blocks as well as ceramics plates. Also, in many cases where large-scale text was required, it was simpler to hand the job to a sign painter than a printer. Images could be printed together with movable type if they were made as woodcuts or wood engravings, as long as the blocks were made to the same type. If intaglio methods, such as copper plates, were used for the images, then images on the text would have required separate print runs on different machines.